Hello, 319K students. I hope you're doing well. Whether you're watching this before or after the exam, I hope it goes as well as you expected it, and I hope you studied really hard for it. But this will be the lab lecture for lab number 4, since we can't have one on Thursday, since you guys are taking your exam. I'll go over the brief overview of this lab and then go into the nitty-gritty a bit later. And if you have any questions, as usual, use Ed Discussion or come to TA office hours. So what we'll be going over today is FSMs, or finite state machines, which you should remember from 306, structs, which may be something new to you, the lab itself, and then any debugging tips that we have. So a struct is a great way to organize data by being able to put different data types into one thing. So kind of what that means is, like, instead of declaring a bunch of different variables to represent something and then make that represent one thing, we can put it into one small little package, and then we can reference each of the components instead to make it easier for us as a programmer. So if that's still kind of confusing, it was for me when I first took this class, this is how we can implement one. So let's say I want to create a graph in C, and I want to establish a data type that can hold my coordinates for different points on a graph. So we need an X variable and we need a Y variable. And instead of declaring like X1, X2, Y1, Y2, and doing a bunch of variables for a bunch of different points, what I can do instead is declare a struct. And then when I use that, I can reference the X and Y variable for a specific point, making it easier for me to know which point I'm referencing and which component I'm referencing. So if we were to implement this with using the point struct from the previous slide, we could set the X variable inside of point 1, which we've declared, and we could set it to any value that we want, and then we know that point 1, its X coordinate is equal to that number. And so what you're going to do in this lab is use this structure to represent each of your different states, their allotted output, their delay, and then any possible states they could go to next, depending on the input of your switches. So the number of outputs that you'll have from each of the states in your FSM graph is going to be 2 to the power of the number of inputs that you have. So because you have 3 switches to represent the south road, the walk road, and the west road, you'll have 8 outputs for each of your states. And so this is what it might look like. Obviously, it'll be much bigger because the solution usually takes 10 to 14 states, but this is the general overview of what it should look like. So each state in a struct, it should have an output, it should have a delay, and then it should have the array of next states that it can go to. So this one only had 4 because it was likely because there are only 2 inputs, but you have 3 inputs, so your array is going to be much longer. Feel free to change the design of this. Maybe if you don't want out to be next, it doesn't have to be. But it'll make it easier because we're implementing what's called a Moore FSM, and this is the general structure of what a Moore FSM is. And so this is what it might look like in C code. And what will make your life easier is using a hashtag define. So what it'll do is that it'll label whatever phrase that you assign it to a specific number. So I can write GoN in my code, and using a hashtag define statement will make it a constant value of 0 to refer to my 0th state. So the lab itself, make sure you edit the 2 EIDs with both you and your partner, because this is the first partner lab. Make sure that you split the work evenly between the 2 of you. So running main 1 will give you what order you're assigned. So let's say you get, if I have all 3 inputs activated, I have south, walk, west, then make sure you follow that order when you're implementing your FSM design. It is different between different people, so make sure that you account for that. If you're only having 2 inputs activated at a time, still follow that order. Meaning that if I have south, walk, west, and then I need to service walk and west, then do walk west in a loop until the input changes. So it doesn't matter that south hasn't been activated, just make sure that you follow the order given to you. And the circuitry for this lab will be very similar to lab 2, only instead of having 1 LED, you're going to have 6 LEDs on your breadboard. It'll be red, yellow, and green for both your south and west roads. And the walk lights are already on your microcontroller, which are the white and red lights of PB22, PB26, and PB27. So this means the initializations are the same, you just have to do a lot more of them from before. So make sure that you write your magic numbers that we like to call them in 319K, your 00000081 or 00040081 as an input, and the DOE register. Make sure that you do that for all of the pins that you're using. This lab does become easier if you label your like input bits to correspond to your states. So like let's say I'm receiving 000 and I'm using the convention that my second bit is the south bit, my first bit is the west bit, and my 0th bit is the walk bit. Keep that convention so that you know which input is being activated during a certain input like combination, and then you know which state to go to. So like let's say 010, that means my west switch is on. That means I need to go service the west road and take care of that. So make sure every switch is getting serviced. Your FSM should be able to handle special cases like having no current inputs, meaning that nothing is being pressed, or multiple things are being pressed at a time, whether it's all three switches or a combination of two different switches being pressed at a time. And one very important thing to know in your design is that the transition between any of the roads, meaning if I'm servicing south and then I'm done servicing south and then I want to go service walk, I need to make sure that there is an all red state in the middle. Now, what does that mean? So that means like, let's say I'm servicing walk right now and I want to go service west. So walk is white right now and the other two streets are red. What needs to happen is that my walk light needs to flash red and then off, red, off, red, off, 3 times. And then all 3 lights on all 3 roads should be red before you go service west. If you don't do that, the grader will not give you your points. So make sure that you're implementing an all red state. There should be at least 3 all red states, meaning that transitioning between any of the roads, there should be an all red state before you start servicing them. And kind of to conceptualize this to make it a little more easier to understand, is we need the all red state to avoid casualties. Like you're an engineer and you're designing this traffic light system to make sure that no one can get hurt and everyone is able to get serviced. And so you need to make sure that no one dies by making sure that the transitions for all the states works the right way. So each of the functions that you'll have to write is traffic init. It's the same thing as the lab initializations that you did in lab 2. It's just that you have a lot more pins to do it for. And then traffic in, that's where you can read the input of your switches to then see what states that you need to go to. And traffic out will write the ones to your LEDs in the D out register to see which ones need to be on at a certain time. And you'll use these together to make sure that you're transitioning through your FSM array of states. Main 2 will help you debug your LEDs by calling your dump from lab 3 to see if it's dumping the right things. Main 3 will help you debug your switches to make sure that they're working. Main 4 will test your FSM call dump to make sure that all of it is correct. And main 5 is basically the grader. And we do ask you to implement delays because it is output, delay, and the next state that you need to go to. And so what we need you to understand is what is SysTick, which is something you probably haven't seen yet. So what SysTick is kind of a delay function that we give to you. And so it's kind of like a timer. So when we write to the load register, that tells it how long it needs to wait. And then writing to any value into the val register will trigger its countdown, and it'll take what you put in the load register and put it in val. And then it'll keep decrementing that register until what's called the count flag is set, meaning that when it detects that the val register has now become a 1 and is about to transition into a 0, the count flag is set, meaning that the timer is done, and then it'll return back to your main code, and then it'll be done with that delay. Or as Professor Balbano likes to say, it is world domination because you get to control the time that you're doing here. Some tips that we have for this lab: design your FSM first before you start coding anything, and have a TA look over it so we can make sure that it looks correct. If your FSM isn't transitioning correctly, even though you got your design okayed, it could likely be an error in the array of next states. Like make sure that it corresponds to the right input value. And make sure your FSM design actually matches with your code. Oftentimes, students don't translate it one-to-one, and then there are some issues with how it's transitioning. Make sure your LEDs and your switches are working all fine before you start coding the FSM and all of the transitions. And double check that you're writing your outputs and reading your inputs correctly. We don't require you to be friendly in this lab, but it is good practice to be. So I do suggest it, but it is also not a requirement. General suggestions for this lab: do your initializations first, design your FSM, and then make your struct. Establish your resting state, meaning that if there are no inputs, what road do you want to be servicing? And then just make sure that that light is either on, like, let's say I want to choose south as my resting state. That means that south, the green light will be on, and the other two roads will be red, and then it'll just stay like that while nothing else is pressed. And then figure out how to update your outputs with the struct. So make sure that you have an out part of your struct declaration so you can write those specific outputs to when you transition to that specific state. And make sure you do that with all states. Your deliverables that you'll have to submit is a circuit diagram, your debug dumps, your gray terminal, and your FSM design. Professor Valvano, when we took this course, recommended the following. So first design your state diagram and then decide the parameters for your traffic out. You can modify it if you want to. We don't suggest it, but make sure that if you do modify it throughout the code file. But generally stick to what we've given you. But you don't have to if you think it's more confusing. Then build your transition table to match the format so that you can use that to build your struct declaration to make it easier for you. And then there should be 3 red outputs, meaning that all lights should be red before you transition into servicing another road, as I mentioned before. There is not only one all red state, there should be 3 all red states. And flashing, like the flashing of the walk light, is not a singular state. It is multiple states. So on that slide previously, when we were talking about the walk light flashing, so it goes like red and then off and then red and then off. That is not one state, that is multiple states. Make sure to reach out to us if you have any questions, but other than that, I hope you enjoyed this lab lecture and have a great rest of your day. Hi, so this is just a circuit demo of what your lab is supposed to look like. So right now it's transitioning between the walk light to another roads, which is why you're seeing the flashing happening on the board. That's the microcontroller LED on the board that you don't have to worry about wiring up. And so it turns green, yellow, red, and then all of the lights are red before I start servicing walk. And then it turns white, red, off, red, off, red, and then it will transition to this one, and then it'll go green, yellow, red. And that's how it'll look like for you after you're done coding this lab.